Hi everyone, this is Robert. I'll talk to you about what we're doing for land cover mapping in the Mekong. This is part of a um, presentation that I put together for our own region where I talked about overall goals of our project, foundations of the methodology, and then our timeline. So I'll skip the overall goals and the flow and just talk about the foundations here. So most of the mapping part of what we're doing is built around Landtrender, which is a time series algorithm, set algorithms to look at Landsat data. There's an example on the right. Got a time series of Landsat imagery. A couple of pixels are picked out. The asterisks in that graph below show the actual spectral response that the sensor brings back. They bounce around because of all the things we know about, atmosphere, sun angle, phenology, whatever. The goal of Landtrender is simply to simplify that with these straight lines. And the initial idea was to use this to discover disturbance, like the fire that's shown on the right. That's indicated by a precipitous drop in an index that corresponds to vegetation. You can also find long, slow processes like decline here. This is insect outbreaks in the Washington Cascades. The point here is that with one pass through the data, you can fully describe this. So the disturbance mapping is something that this was sort of initially identified for, where we can identify those segments of precipitous drop, map them, do things with them, make them into patches, label them, etc. But what's interesting is that by simplifying the year-to-year variation, we can then actually work with those data as pseudo images and classify them after the fact. And so this piece that I just added here, the lower left figure, is different indices. These are the tassel cap indices conforming to the patterns that were found with a detection index, in this case NBR. And the notion here is that those tassel cap images on the bottom can be used directly in a classification. You can just take a slice out of any year of those smooth lines, those temporally smooth lines, and capture the spectral progression without all the year-to-year noise. That allows you to take a map that's in one year and paint it backwards and forwards to other years. And that's what this figure basically shows, is that if we have a map in the US, we use National Land Cover Database, but you can use anything. You extract the spectral data from that time period, the smooth spectral data, and then you can paint it backwards and forwards. So really the nice thing about this, and sort of the selling point to me, is that there's tons of different ways of doing disturbance mapping. There's tons of different ways to do classification. What's nice about an approach like this, and it's not the only one, is that they're consistent. So the temporal segmentation drawing those straight lines underlies both the maps of change and the temporally smooth imagery used for the classification, which means that those endpoints, the yearly land cover maps and the maps of the change agent, agree. And that allows you to do analyses. So for example, in the western states, we looked at, this was a carbon project looking at forests and disturbance agents. And so you can map both the disturbance agent, like the middle graph, and this is just summarized to these hexagons, but it is at the 30-meter scale in the native data. Lots of fire, this is sort of the area of fire, but then the biomass impact is a function of both how much was burned and what kind of forest was burned, and that's a different story spatially. And the nice thing is that those two products, the change and in this case the biomass map, the yearly biomass maps, are consistent. And then you can summarize them and tell stories about where carbon came and went, etc. So that's what this is. The core of this, the temporal segmentation, happens in Earth Engine, and then we pull stuff down, that's in the left, and then we pull stuff through Google Drive onto our own local servers to do some additional processing, things that are not as tailored to what Earth Engine is good at, or things that we already have a pretty voluminous library, and it'd just be a pain in the butt to translate it all into Earth Engine. Plus, this allows us to keep intermediate products, etc. So we have some examples of this. You can go look at the website. Yearly land cover maps of various flavors for the U.S. And then we've begun to, for the proposal, we wanted to make sure we could even do this. So we did some initial segmentations and disturbance mapping, not the line cover part, because that's much more involved. And that's what we're planning to do initially in Cambodia. It looks like after SAGE, I'm going to say we're also going to help out with Myanmar and, well, probably Myanmar and Cambodia to start with, I guess. So And that is it. I'm not going to talk about the flow. Thanks.